Hey, Sophia. Hey, Eli.
Hi.
Hey, Sam. How are y'all today? Hey, Annabella. I got some emails on some different things to do. So I'm going to start with the emails, the emailed questions. And then if y'all have some outside of that, I'll work on those. The ones that I got emails about were number 5, number 7, numbers 11 through 16. I got questions on X and Y tables and graphing in general. So I'm going to cover doing XY tables. I'm going to cover doing X and Y intercepts. And I'm going to cover the slope intercept form. And I'll do it using a lot of the equations that are on the chapter test review. And I also got a question on number 25 from yesterday's classwork, and I'll be handling that as well. And then I also had a question for a review on domain and range. But I'm going to start on page 1 of the review. Once again, one other thing that I want to clarify just to make sure everybody knows this. I'm going to write in the quadrants for numbers 1 through 4, just to remind everybody how they're labeled. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. So it goes in a counterclockwise fashion, beginning at the top right, and then goes counterclockwise. So tomorrow, if asked to plot points, you want to make and describe the location. It is either looking for the quadrant or it is looking for the X or Y axis, like number 2 is. So I just want to review that piece. Now, to move on to number 5 through 7 on graphing the equation. I'm going to do a couple things on this part. I'm actually going to move over to a blank piece of paper and then go back to the graph. So the problem is 3x minus y equals 5. I believe I wrote it down correctly, right? Yes.
Why does the first one say it's in quadrant? Because quadrant.
Good catch, Sam. Good catch. Absolutely. I see what you're saying. Yes. So I hope, Eli, if you're there, noticing that, yes, Mrs. Sparks graphed that wrong. It's -1 and then +3. So my bad, ladies and gentlemen. I think almost everybody that's here was in Math Lab the other day. That's -1 and then up 3. So it goes right there. So yes.
Thank you.
That is very true. Thank you. So over 1 to the left and up 3. So the answer to that one is quadrant 2. I think I graphed that actually in reverse because I think I graphed it here and that's incorrect. So yes, even I still get my X's and Y's mixed up. So be very, very careful. Let's just double check to make sure I did the rest right. 4, 0, which means I'm going to go over 4. 1, 2, 3, 4, 0. So that one is correct, and it's on the x-axis. And C is over to the right 2 and down 2. I did that one correctly, and it is 4. And D is left 1, down 1. And that is in quadrant 3. Good catch. Everybody see those? All right. I apologize for any confusion on that. Bless y'all's hearts. Because I do want to make sure that you guys know how to do that, because you need to be able to plot them, and you also need to be able to read the graph. Like if, let's just say, for instance, I'm going to plot this point right here. I'm going to make it a different color. Can anyone tell me the coordinates for that point that I plotted that's purple? What is the x coordinate for that?
4.
4, 3.
Good, 4. And then somebody said 3. Good job. That is it. So for the test tomorrow, you need to be able to plot them when given a point, and you also need to be able to read them and give the x and y ordered pair. Does anybody have any questions on that? Then I'm going to go ahead and move back to 3x minus 5, and 3x minus y equals 5. Okay, we've learned primarily 3 ways to graph. The very first one that we learned was an x and y table, and that's where we pick 3 values for x. And the reason why we pick 3 values for x is our dependent or independent variable. Independent variable. Meaning whatever you put in for x into an equation like the one shown here, you'll solve for the y. Okay? So, and remember, Mrs. Sparks typically picks -1, 0, and 1. So you go in and you plug in -1. And 3 times -1 is -3 minus y. And we're solving for y. You can't leave a negative on the y, so you have to divide it by a -1. And so that gives you a -8. Then we're going to plug in. Did everybody get that before I erase? I'll start up here. Then I will plug in 0. An x and y table is just basically a chart of values.
For the
0
test,
minus
we
y.
just pick one way to solve it.
I'm sorry?
For the test, should we just pick one way to solve it?
I would, unless otherwise instructed. Like might be a question on there that would say, what is the x and y intercept? Then obviously it's asking you to specifically solve it a certain way. Does that make sense?
Yes,
If
ma'am.
you're not told how to graph it, I would absolutely pick just one way and master it. But you need to know the other ways because it's important for, other things. Does that make sense?
Yes, ma'am.
Okay. So 0, -5. Now, what we're doing by creating an x and y table is we're actually creating values or ordered pairs. So now we're going to plug in a 1. Oops. Shh. Hey guys, I'm in math lab. My children are fighting. So y equals -2. So now I've got 3 ordered pairs, -1, -8, 0, -5, and 1, -2. So -1, 8, -1, 1, 2, 3, 4, 5, 6, 7. Oh, she's all the way down here. And then 0, -5. And then I think it was 1, 2. Is that right? 1, -2 or 1, 2?
-2.
Thank you. Okay, that's one way to do it. The other way that you could have done this is by finding the x and y intercept. I've already found one of those. Can anybody tell me which one this would be? I plugged in a 0 for x, so what would that be? My y-intercept or my x-intercept?
Y.
Yes, good job. So now I'm going to find the x-intercept by plugging a 0 in for y. So I've got 5/3 or 1 2/3 roughly as my x-intercept. So that would be another way that you could do it. And you can kind of see over here that it actually worked even when I plugged it in using the x and y table. Does that make sense to you guys? How my line actually even worked. So and then here would have been the y-intercept. I'm sorry, say that again.
How would you graph it when it says 5 over here?
How would you graph it if it said find the x and y intercept?
Like 5/3.
Oh, how would you just breaking that down to if that's going to be 1, good question, and 2/3. So you're kind of guesstimating like I did here. I'm going to use yellow. You're kind of guessing it's going to be between 1 and 2. It's approximately 1 2/3. It's going to be somewhere in between the two, and I made it in yellow. And this actually is the this is the x-intercept, and this is the y-intercept. So you can see, because I'm kind of using that same equation to do, I did the x and y table. And so and then I did the x and y intercepts.
So I think, do you think you're going to do a table?
You will do a table on the chapter test tomorrow, but it will be more of a function table. For graphing, what are you going to do for graphing? For graphing, in all honesty, you're going to use the X and Y intercept.
Okay. So you would only have to find
that. As long as you can, and they actually, to be honest with you, the X and Y intercept are given. So let's talk about that for just a second. See the two yellow points on the graph? Does everyone see those? Mm-hmm. Basically, this is the y-intercept down here. And this is the x-intercept here. So you would connect them. You put them on there and you connect them. Like I said, the test is easier than the review. As long as y'all can do the review, you should be able to do the test. Because on the review, I need to make sure that you guys absolutely know how to use an X and Y table, how to distinguish between an X-intercept and a Y-intercept. And we're also going to put this same equation into slope-intercept form so that you know all three of those, because we need to know all of those before we move on to the next chapter. So going back here, I'm going to look at this equation, this 3x minus y. Equals 5. And the last thing we're going to do is put it in slope-intercept form. And that means you're solving for y. So I'm going to subtract 3x from both sides of the equation. And that's going to give me negative y equals negative 3x plus 5. Cannot leave that y as a negative. So I'm going to divide everything by a negative 1, which basically just changes the sign on each of the terms. So if I were using this to graph the line, which this is my personal favorite method, but it doesn't mean it has to be yours. I would have graphed the 5, the negative 5. And then I would have used my slope, which is 3, because the slope is the leading coefficient on the x term. So I would go up 3, 1, 2, 3, and right 1.
Yeah, that makes more sense.
Does that make more sense to you? Is that the method you like? And then you would go up 3, 1, 2, 3, right 1. But you can see how my line 1, 1, 2, 3, right 1. You can see how that all three of these methods, the first method we used was an X and Y table. The second method that we used was an X and Y intercept. And the third method that we used was putting the equation in slope-intercept form and using the y-intercept and the slope to graph the line. But as you can see at the graph itself, all three of these ways worked. All three of these methods show me where various points on the line are. So any method that you choose will work. You just need to pick one and definitely become proficient. You just need to understand how to do them all. Does that make sense? All right, let's look at number 6. I'm going to switch back over to the Google Hangout and tell me, what method do you all like best? Should I try on this? Do you want me to convert it to slope-intercept form?
That one's easiest to me.
It is easiest to you?
Yes, ma'am.
Okay.
Except for 7. I made a chart.
Okay. And I kind of understand what you're saying on that one.
Because then you have to add 0 to 7. More confusing.
Okay, I see. Yeah, I do understand what you're saying on that one. I'm gonna try to talk in general on how to approach when they're vertical and horizontal lines. Okay, number 6. Did everybody say slope intercept form was the easiest for you guys? Or do you like doing the XY tables? I feel like Sophia and Samantha both. You like the XY table? Okay, I'll do that one, and I'll do slope intercept. All right, I'm going to do it 2 ways just to go over it. Thank you for letting me know, because all right, let's take that. Makes the most sense to you because you're getting coordinate pairs. And plotting them. Or do you just not like? Okay, cool. Thank you for letting me know. Because really, a lot of this, is up to you. You will find that when an equation is given in function notation form, it's already in the slope-intercept form. So it makes it very, very easy. Although on the back side of this paper, we're going to see how to fill out an XY table when it's in function notation. That's one of the things it asks us to do. So number 6 is 3y minus 2x equals -3. So an x and y table, -1, 0, 1, where I'm going to plug in 4x -1 and see what y is. Yes.
For number 6, if you were to do just finding the slope.
Yeah, I'm going to do that one next.
Would the answer be y equals -1 plus 2 over 3x? Or would you have to find the slope?
I have not worked it completely out yet, so hang on just a second. It looks like the slope would be 2/3.
Yeah, that's what I got.
Yeah, it would be the slope would be 2/3, and the y-intercept would be -1. If I'm doing it right in my head. So yeah, you could definitely, do that. And I'm going to do that next.
Okay.
So we got -5/3. Oh, how did that get erased? Ugh. Then we're going to stick in a 0 here. And then we'll stick in a 1. Is that, I must have done something wrong. Oh, I know what I did wrong. I got to add, oops. This would have been -2, and this would be +2, and this would be a -1 divided by 3. So y equals -1/3.
How would you write that in the answer blank?
On the answer blank, on these, you're probably going to do something like C graph.
Oh, okay.
And then so for that, we had -1. Yuck. The -1 is the y-intercept, and this is going by increments of 2. So, and then with 0, -1, and then we had -1 5/3. So over left 1, and then we're going to go by, that's going to be 1 2/3. So this is going to be tough to graph because it's going by increments of 2. And then on top of that, we're going in increments of 1 1/3. So this is going to be fun. I wonder why it would make a graph going by 2s when the slope is 2/3. So 1.
That's what I said.
Is it really?
Yes, I read this and I was really angry at the graph.
I know. I was like, why did they even do that? So annoying. All right. So we have negative. So I'm looking at -1 2/3. So I'm going to go over just a little bit. -1, and then down. It's going to be about right here. Like my points aren't even going to be very far apart using this. And then I've got a +1, and then 2, and then what was it, a positive? And then a -1/3. Yeah, they're not even going to be very far apart. Look, it's going to be about right there. Anyway, that's your line based on the XY table. Yay! I'm like, okay. So yeah, halfway between and then down just a little ways. And since the graph is kind of wonky, but oh my, it would have been easier to do this one definitely if the graph would not have been in increments of 2. So my apologies on that. I need to make a note of that next year. I wonder, I guess, I don't know what happened. All right.
So show our work and maybe make a different graph to the side of the one given to you. Will we get credit?
Yes. We get credit. Oh, absolutely. You would get credit. Absolutely. That was
threw me off.
Yeah. Yeah. I can totally understand and respect that. You know, sometimes I think it's a blessing to have the graph provided for you so that you don't use your own graph paper and have to draw your own stuff. But then sometimes in cases and scenarios like this, it's like, I would not have done that to myself. So in slope-intercept form, the equation would look like this. So what you would do is I'm going to do this one in yellow again. So your intercept would still be that 0, -1. But now we're going to use the slope, which is 2/3, to go up 2 and 3. So 1, 2, and then right 3. 1, 2, 3. And then down 2. 1, 2, and left 3. 1, 2, 3. So they're still on top of each other, but wow. That was quite a challenge.
Miss Sparks, I have a question.
Yes, ma'am?
Do I have to be somewhere? And I have a lot of on other sheets.
On other sheets?
Yeah.
Do you mind telling me which ones they are, and I'll write them down and I'll get to them, and then maybe send you the link and tell you where to begin?
Yes, please.
Okay.
Okay, so
Tell me what they are.
hold on.
Or I tell you what, sweetheart, why don't you email me and I'll do that, so that way I'm not taking up Matt. Do you mind doing that?
Yes, please.
Okay, so just email me with the pages and all of that stuff, and I'll make sure I get that to you, because I got an email from another student while I was on Math Lab that I've got to do that too.
Okay.
Okay. All right. Yes.
Thank you.
Graph. I
Oh, you're welcome.
squares in half and like I drew little increments on the line. One it was. So I got X1. And I just went down to negative one. Two half squares. So it was like halfway that first square up above the origin. And then I moved over three halves.
Right. And that's what I did.
Well,
Isn't it?
I don't know. It's a little different because full squares. So I don't know if I did mine right.
This looks like this is in the half square, isn't it? It's supposed to be. Does it not look like it from your end? Yeah, I did. I thought I did oh, maybe I didn't do half squares. I bet I didn't. You're probably right. I may not have.
I hate this graph.
1, 2. I see what you're saying. 1, 2, 3. My intention was to make it half squares, but hang on. But perhaps it isn't. 1, 2, 3. Does that look better? Does that look better?
Mine's still wrong. I think I did something very bad.
I don't. Maybe you didn't.
Where's my
1, 2.
Okay. Throw my glasses.
Maybe it's here. Maybe I'm counting over too many. And then down 1, 2.
Like I cut every square.
In half?
Yes,
You
ma'am.
cut every square in half. I got what you're saying, which is fine. It's just very difficult to graph a 2/3 thing on something that goes by twos.
Yeah.
So, however, on this particular one, I would never do that to you guys on the thing. So I need to just eliminate this because it's very difficult. Number one, when you're graphing in 2/3, the slope being 2/3 is not a hard. It's not a hard thing, but slope being 2/3 is not a hard thing as long as your graph is going in increments of 1.
So would the
But
slope
all right.
and then run 3 spaces to the right?
Yeah, the slope would be up to 3 spaces to the right because it's positive, right?
Yes, ma'am.
Okay. So you would go up to 3 spaces to the right or down to 3 spaces to the left.
Okay.
So if I didn't, here, let's just, took the old graph off, which I'm sorry with the X and Y table, but let's just start fresh. And if y'all see me counting, maybe that'll help. 1 is going to be halfway in between here, right?
Yes, ma'am.
And then we've got 2/3. So you're going to go 1, 2. And then you're going to go, and it would be there. Then you're going to go 1, 2, 3.
Yeah, that's exactly what mine looked.
Okay. So I probably did count. I counted full spaces is probably what I did. Because
I really dislike this graph.
Yeah, it's not a pretty thing. 1, 2, 1, 2, 3. Yeah. The graphs on the test won't be in increments of 2. I just double checked just to make sure, y'all. I was like, please. There is 1 on the test that's in increments of 2. There's actually 2 on the test in increments of 2, but all you're doing is plotting an X and Y intercept, and they're both divisible by 2. So you'll be fine. And all you have to do is plot the X intercept and the Y intercept. And so you're connecting 2 dots. And I'll actually go over that. Literally give you an example of that I've got some graphs pulled up. All right. Very specifically, when we're doing Y equals -3. Y equals -3. This one actually goes by increments of 2 as well. So you're going to actually do this. And I think I counted it the other day. I think I counted them by 1s. But it is a horizontal line running completely through all of the Y's that equal -3. So look, these are normal graphs. I probably should just graphed it here. Y equals -3. You don't really need an X and Y table. You don't need to show any work. I just need to know that you know that that is a horizontal line. X equals 2. I need to know that you know that is a vertical line. Y equals 4. That is a horizontal line that runs through 4. X equals -1. That's going to be a vertical line that runs through -1. So X equals are vertical lines. Y equals are horizontal lines. Y'all, and that's the only thing. I don't need to see any work, or you don't have to do an X and Y table. You don't have to do anything. It's just something that you need to know. Wouldn't have to show me any work. You just need to know that it's a vertical line, X equals 2, because no matter where, I mean, you could show it to me if you wanted, but basically what you're saying is that Y can be anything. It could be 10, it could be 2, it can be 0. It's still going to be X is 2. And then over here, Y equals -3, no matter what X is. because essentially there's no x in that equation. Does that make sense? Does that help you all with vertical and horizontal lines?
Yes, ma'am.
Yes, ma'am. Okay, good. All right. X-intercept and Y-intercept, 8, 9, and 10. What you do on these is just put in, and this is, let's see. Oh, here's something. I know I want to do this. I'm going to have you all walk through this. I'm going to go back to my blank graphs. If I said to you x-intercept is -2 and the y-intercept is 4, what would you do? And I would say graph the line. What would you do? Where am I going to put this point right here?
It's negative, so move 2 to the left.
Okay, move 2 to the left. And I'm going to put a dot right there because it intercepts the x-axis. And now what am I going to do with the y-intercept of 4?
Start at the origin and go up 4.
Start at the origin and go up 4. And it's on the y-axis. It intercepts the y. And then you connect the 2 points. Is everybody good with that? Could you do that on your own tomorrow?
I think so.
Okay. That's how you're going to have to graph tomorrow. You're not given an equation or anything like that. You're literally given the x-intercept and the y-intercept. You plot those 2 points and then connect the line.
What numbers?
Those are not on the. Those are not specifically on this review sheet. I'm just making sure you understand the concept of what an x-intercept is, what a y-intercept is, and how you can use them to graph. I did that on number 5. It was one of the ways that I showed. But I'm just making sure that you understand it. I'm covering it because it is on the test, but not on the review. That's why I'm stopping for a minute to make sure everybody understands it. Because on the review, we have to solve for the x-intercept and the y-intercept, but solving for it and understanding how to put it on a graph is sometimes 2 different things. So I'm making sure that you guys understand how to plot the point. And then we're going to move into actually solving for the x-intercept and y-intercept. But I want to make sure that you all understand how to graph it. Does that make sense to you guys?
Yes.
Okay. I don't want to move on unless it does. All right. Now we're going to, in numbers 8, 9, and 10, we're going to learn how to solve for the x-intercept and the y-intercept. Okay? Okay, this is number 8. 6x minus 4y equals 12. To find the x-intercept, you plug in 0 for y. This becomes 0. So now we have 6x equals 12. And we'll divide both sides by 6. So 2 is our x-intercept. And to find our y-intercept, you plug in 0 for x. Now we're going to divide both sides by 4. We have y equals -3. So that's how you find the x and the y-intercept. If I were to plot those, you don't have to. This was not part of the homework, but I'm just making sure that you guys understand it, okay? 2 and 0. And 0 and -3. So this is the x-intercept, and this is the y. So 2 and -3. And if I said to graph that line, you just connect the 2 points, and there's your line. The next one that I was asked to do was number 10. Did anybody need me to do 9? Since I skipped from 8 to 10. Is everybody good on 9? I was asked about 10.
Can you do 9, please?
Yes, I can. -2x plus 5y equals -10. So to find the x-intercept, I'm going to plug in 0 for y. This becomes 0. And then I'm going to divide both sides by 2, -2. And I'm going to need a +5. And to find the y-intercept, I'm going to plug in a 0 for the x. That becomes 0. Divide both sides by 5. And y equals -2. So my y-intercept is 0, -2. So number 10.
Miss Sparks.
How are y'all doing? Yes.
With the answer for number 9, you just put x equals 5 and y equals -2.
Could you, are you saying, could you write that in the blanks to the right?
Yeah.
Yes, I would accept that. The reason why I don't do it in Math Lab is I didn't want anyone to get confused. I mean, I absolutely will understand what you mean. I did not want to get anyone confused between a horizontal and vertical line. So that's why I've been putting it in an ordered pair. Does that make sense, Sophia?
Kind of.
Because, you know, just a second ago, I believe that the x equal 5. Was that correct? And y equal -2. I can't remember now.
Yeah.
Yes, ma'am.
Okay. If I wrote just that, remember when we were back over here and I was talking about vertical and horizontal lines, and it would be like x equals -1. Does that make sense? This is a line.
Yes, ma'am.
And this is a y or an x intercept. And I didn't want there to be any confusion. So I've been writing, what I've been trying to do is make a habit of writing my answers in an ordered pair when it was an x intercept, because I did not want to confuse you guys. It is fine if you give me the answer on a test and it says x intercept or x equals 5. I will absolutely know what you mean. And I don't have a problem with that. But I did not want to cause anyone confusion about the difference between an x-intercept and a full horizontal or vertical line. Because like this x equals 2 over here, this is a vertical line. Did I clarify that for everyone okay?
Yes, ma'am.
Okay. How about you, Sophia? Did that help? Or is it still a little fuzzy?
It helped.
Okay, great. That was the only reason I didn't do that. But I think originally in class, Sophia, if I'm not mistaken, I think that we actually did write it x equals. So I understand completely what you're saying. I just thought because we definitely need to know that sometimes that x equals 5 is an equation and not just a point on a line or a coordinate on a line. All right, number 10, y equals 1/2 x minus 2. All right, to find the x-intercept, we're going to plug a 0 in for y. So, and now we got 1/2 x or 2 equals 1/2 x. And now to get clear of fraction, you're going to multiply both sides by the reciprocal of 2 or 1/2, which is 2. So 4 equals x. Sorry about that. Does everybody understand that?
Yes.
Okay, good. And now we're going to do This one isn't as bad. I know y'all hate it when there's fractions in there, but luckily now you get to find the y-intercept. You're going to multiply you're going to plug in a 0 for the x. That becomes 0, and you've got -2. So that was 8, 9, and 10. Any questions about x and y intercepts? Okay. I know we went through this in Math Lab the other day, but I did get a lot of emails again to go over numbers 11 through 16, and particular number 11. So determine the rates of change in distance with respect to time. And we're using the graph to the right, which shows the distance of a car traveling along a straight road for 8 hours. A positive velocity in motion is a motion to the right, and a negative velocity in motion is to the left. So for number 11, we're actually going to have 4 answers because we have to find the distance from here to here, or the ratio of distance with respect to time, and then one from there to there, one from here to here, and then one from here to here. So we've got 4 different answers. So let's just start from 0 to 2, because you're going from here. So we've got 60 minus 0 over 2 minus 0. So we're basically using our slope formula, 60 over 2, which equals 30 miles per hour, because this would reduce to 30 over 1. So my first answer is 30. Whoops, my bad. Put it in the wrong box.
Is this going to be on the test?
There is one like this on the test. Yes.
It's the one on the test. Does that one have 5 parts?
The one on the test has 2 parts.
Okay, that's good.
And you have to determine the rate of change, which I'm doing right now. And then tell what direction it's traveling in based on the rate of change. So we're going to talk about that moving down, okay? So rate of change is slope. All right, so then I'm going to erase this one. But yes, there is one like this on the test. Being able to, just to read the graph. I'm going to erase this one. And then the next one that we're going to talk about is from here to here. So we've got 120 at the top minus 60, because this is our y-axis. So that goes on top. Our change in y goes on the top. And we're going from 3 to 2. So 3 minus 2. And 120 minus 60 is 60. And 3 minus 2 is 1. So your second rate of change is 60 miles per hour. Our next rate of change is from here to here. So we've got 120 minus 120 all over, and then it goes from here to here. So it's going to be 3 minus 4. And that equals 0 over negative 1. But that's basically 0 as the rate of change.
This makes no sense to me.
Okay. Thank you for being honest, because I'm sure you're not the only one. I appreciate you speaking out.
Why is that one? You said it was 0. You said it was 0. 1.
Well, either way, I could have done it either way. You could have. It's not going to make much difference because I've got 120.
If it's not moving, it's left or right. Left or right.
You know, so I could have done 4 minus 3. I'm still going to get 0 over 1. It's still going to be 0 because it's not moving. So it's actually on this particular graph, it's probably not going to make much difference. But the key is that you're always keeping your Y1 and your X1. So if we're like this one right here, okay, let's go back and just read them as ordered pairs first, because I think that will help Sophia a little bit. This is still an X and Y table because this is X and this is Y. So for slope or rate of change, which that's what we're doing, slope is a rate of change. Okay? So for a slope or rate of change, you're looking at the change in Y over the change in X. So what is the coordinate for that dot that I just circled? What are the coordinates for that?
60 over 2.
Well, yeah, but if you were giving it to me in an ordered pair, you would tell me 260, correct?
Yeah.
Because 2 is the X and 60 is the Y. Okay. What is the ordered pair for here?
0, 0.
Yes. So when you're figuring the rate of change, it's 60 minus 0 over 2 minus 0. Because it's Y1 minus Y2 or Y2 minus Y1. It doesn't make any difference. You just have to make sure that this ordered pair here is on top of each other. And this, oops, yeah, my bad. Didn't mean to circle it that way. This ordered pair is on top of each other. And this ordered pair is on top of each other. So that's how you keep rate of change together. Does that help or no?
Yes.
So that was our first rate of change. Okay, good. So our first rate of change was 30 miles per hour. Now, the coordinate for this one is 3 and 120. And we're comparing it to this one that we've already determined is 2 and 60. That's the ordered pair. So we have 120 minus 60 over 3 minus 2. So the change in Y over the change in X. And that's 60 over 1, so that's 60 miles per hour. And then the rate of change here was That was
what are the two answers for number 11?
What are the two answers?
Yeah, why are there two answers?
There's actually a total of 4, and it's 30 miles per hour and 60 miles per hour. And then we did determine one of being 0, but I'm reworking that now, but I'm putting it in ordered pairs in the hopes that that will make more sense. Is this making more sense to everyone?
Yes.
Now that I've put them in ordered pairs?
Yes, ma'am. Yes, ma'am.
Okay. And it really doesn't make any difference which ones go first with ordered pairs. It just makes, it's very important that one ordered pair is on top of another ordered pair. But then you've got 0 miles per hour for that one. And now our final rate of change is going to be this point right here is 4, 120. And this point right here is 8, 0. So we've got 120 minus 0 over 4 minus 8. So we've got 120 over negative 4, which gives us a negative 30 miles per hour. Now that sounds weird to us, and I realize that, but let's go back and read the paragraph because this is crucial for tomorrow as well. Let's read the paragraph that states in the original, a positive velocity is a motion to the right, and a negative velocity is a motion to the left. So this would be a motion to the right because it's positive. This would be a motion to the right because it's positive. But this, however, would be a motion to the left because it's negative. All right. So I'm going to skip number 12 for the time being. Between what two times is the car traveling to the right? So the positive velocity is the traveling to the right. So basically, it's actually traveling to the right all the way up to here from 0 to 2 and 2 to 3. So you actually could write down from 0 to 3 if you, not for that, Miss Sparks. You could actually write down 0 to 3, or you could have written down 0 to 2 and 2 to 3. However you want to write that is fine with me.
It was that question that was confusing me the most.
Oh, okay. Either way that you want to write it. You thought it wanted you to what?
I thought it wanted us to pick like one interval out of the four. So I said 0 and 2.
I got you.
0 and 2. All we're moving.
Yeah. Well, it doesn't matter. You could do 0 to 3, or you could do 0 to 2 and 2 to 3. That really, I think by saying what 2 times, it's basically asking you what this part of the graph right here, you can kind of tell is a positive velocity, but I would be okay however you wanted to write that. If you wanted to write it out like that. Does that make sense?
Yes, ma'am. Will that sort of thing be on the test?
Will that sort of thing be on the test? Yes. Knowing when it's traveling with a positive velocity that it's traveling to the right, yes, that will be on the test. So you would have to be able to find the rate of change and determine whether that rate of change was positive or negative.
That part's easy. It's just I was confused by the wording of the question.
Yeah. All right. Well, let's take a look at it. So it says a negative velocity is a motion to the left. Which one of these rates of change is negative?
Negative 30 miles per hour.
The negative 30 miles per hour. And you can also tell the negative velocity by the fact that this is going down. So that would have a negative slope. This has a positive slope, right?
Yes, ma'am.
So that's another way to tell. Okay? All right, so between what two times is the car traveling to the left? The negative slope.
I think I said 4 to 8.
4 to 8. Does everyone see that? That is correct. Is there anybody who's struggling with that? From here to here, you have a negative velocity. So 4 to 8. Between what two times is the car traveling the fastest?
2 to 3.
2 to 3, because it was 60 miles per hour. It's your greatest rate of change. All right, I'm going to go back and hit number 12 now. Between what two times is the car not moving?
3 and 4.
3 and 4. So that was up here. It's staying still right here. All right. There won't be one like this on the test, but what does the x-intercept represent in this situation? So it's hitting the x-axis right here at 8. And so basically it's just determining, yes.
Sorry, I interrupted you.
Yes? No, you're fine. Did you have a question?
Not pretty much a 0. It's
the graph.
Yeah, it is a 0 of the graph. And so basically what this tells you is that the car traveled for 8 hours and then returned to its starting position.
So the car kind of starting and stopping.
Yes. But you're really focused on this because this is just the origin and this is the true x-intercept, so that the car traveled for 8 hours and stopped.
So that one won't be on the test?
No, ma'am. That one will not be on the test.
Thank you.
No problem. Definitely need to focus on 11, 13, and 14 on this. Okay. Identify the slope and y-intercept. I don't know. Does anybody want me to go over 17, 18. I did not have anyone email me about those, but now that I'm here, is there anyone that would like me to do that? Just to be sure, what is the slope on 17?
8.
Good job. What is the y-intercept?
-3.
Good job. Okay. And for 18 and 19, you would have to get them into slope-intercept form, or y equals mx plus b. Is there anybody who's struggling with that and needs me to do those?
I think I understand it, but my answers aren't.
Your answers are ugly? I hate ugly answers. Let's just check it out real quick. Negative y equals -2/9 x plus 1. Did you get that?
Yes, ma'am.
Okay, so the slope would be -2/9, and the y-intercept would be 1.
Yes, ma'am. That's what I got.
Yeah, I know. It is. The slopes can be ugly when they're in fractions like that, but you know, as long as you don't have a graph that goes in increments of 2s or 3s, they're not that bad.
Yeah.
It certainly gives a great argument for using your own graph paper. All right, let's do this one. We're going to add 3x to both sides. Got -4y equals 3x minus 16. Divide everything by -4. And we should have y equals -3/4 x plus 4. So slope is -3/4, and y-intercept is 4.
That's what I got.
Okay. Number 20, 21, and 22. Those are definitely on the test. So
Can you do
how many people need me to go over those?
Can you do one of them?
Yes, ma'am. Absolutely. Number 20. And once again, you know how Miss Sparks likes to rewrite her points because they need to be vertical for her. You saw that sometimes all that can get a wee bit confusing. 3 minus 1 over -4 minus a -1 equals 2 over -4 plus 1 is -3.
How would you label the numbers again?
I don't actually. Did you get something different?
Yes, ma'am.
I did too.
I got 4 over.
Did I
Yeah.
write down my number? Oh, you know what? I didn't make this a negative.
Oh.
So that's -4.
Wait. But if it's -3 minus 1. Oh, okay.
Oh, okay.
So you got 4/3?
I also did. Made my
Love the feedback.
I'm not even wearing it.
I know feedback is so bad. Isn't it awful?
Ooh, boy.
Bug. So did you all get 4/3?
Yes, ma'am.
I got 4/5.
Okay. How did you set yours up? Did you set it up my way, or were your coordinates different?
Because
it doesn't matter. You did it the same way as me? Okay. When you do here, 4 minus a -1 is 4 plus 1. And then a negative plus a positive, you find the difference and give the sign of the higher, and that's where I got -3.
Okay.
Does that make okay. Now, and then someone asked, how do you label your points? It really doesn't matter how you label your points. Like, honestly, you're going to get the same thing. If someone made their points, if this were X1, Y1, and this were X2, Y2, it wouldn't make any difference. You're still going to get the same answer as if somebody else did this one as X1, Y1, and this one as X2, Y2. It doesn't matter. You're still going to get it. So does that make sense to you guys? It doesn't matter. What matters is the fact that you keep them consistent, that whatever you determine to be your X1, Y1, you keep it in those positions on the top and the bottom.
And then it's
but it
Y2.
really doesn't make
X2. Sorry, I keep interrupting you.
No, you're fine. The slope formula is, X2 minus Y1, and then over. So basically it looks like this. But some people some people just do it like this. You're going to see it written all kinds of ways. It's just the change in Y over the change in X. So it's not, you can see it written many different ways, but this is your formula for the most part. You're just looking for the change in Y over the change in X. So you're subtracting your 2 Y coordinates from your 2 X coordinates. The reason why they start putting the subscript numbers on there is to ensure that if I use this point first on the top, then I have to make sure I use this point first on the bottom. See how they're together? And then this point is together. That's the key. keeping them on top of each other when you plug them into the formula. Does that clarify it for you guys a little?
Yes, ma'am. Yes, ma'am.
Okay. I want to make sure that it does. All right. There was a typo on number 24. So I want to make sure I correct that now.
Miss Sparks.
Miss Sparks.
Yes, love.
On number 21, I got 0 over 5. So would that be vertical?
Would that be vertical line?
I mean horizontal.
You got 0 over 5?
Yeah.
Is that what you said? You got 0 over 5?
Yes.
Yes.
Yes. Yes. That would be a actually a horizontal line.
Yeah, that's what I meant.
Okay. All right. Yes. 0 fun to ski on a horizontal line.
Do we need
Yes.
to know parallel
I can
and
fill in. Say that again.
Do we need to know parallel and
You do not need to know parallel lines. We're going to get more into that into chapter 4. It was just an introduction to it this time to introduce the concept that parallel lines have the same slope. But we're going to get more involved into that into the next.
So on the test, we don't have to look at it. Parallel or not?
No. No, you will not.
Yay. Okay.
Yeah. Yeah.
Wait, why'd you put 0 for
And I'm
number
just going to go ahead and
for number 20.
number 21 is yes. If you wrote 0 over 5, that's fine, but it's 0.
If you put horizontal line, would that be okay?
Yeah, that'd be great. I'd love to know that you knew that. But I do want you to write at least something. Oh. I don't know what caused that. I have no idea. Pretty music. But I do need to know that what the value of the slope is. Does that make sense?
Okay.
But if you add horizontal line, that would be the bomb. Okay. On this one down here, this 0 is a typo. Oh, I quit writing. I think I have a thing, guys. I'm going to have to stop Math Lab. Can everybody hear me?
Yes. Yes, ma'am.
Yes.
Okay. Hang on just a second. I think, no, I haven't been. Okay. Never mind. I think sometimes math, like the Google Hangout just stops after so long. Hang on. And I'm going to have to close the test for a second and bring it back up. Because it quit writing on me, as usual.
For number 22, if it was negative 6 over 3, I simplify it.
For 20, what? Tell me the answer again, please.
I got negative 6 over 3.
negative 6 over 3.
Would I simplify that?
Yes, you would. Yes, ma'am. You would simplify that. Yes, please.
So I could just put negative 2 as the answer?
Yes, ma'am.
Wait, for which one? This 22?
She asked which one?
This 22?
Yes.
Okay. I got -2 as well.
Yes, that is the correct answer. On number 24, let's see if it works this time. That is a typo. But we're going to complete the table for the function because this was also a question that was asked. And so for x, what it's telling you is you're going to plug in a value. When it's this part of the table here, you're plugging in a value for x to find a value for f of x. So we're going to plug in -1 to find what f of x is, or f defined at -1.
5.
Good job. So then you would put the 5 right here.
Do we just say C chart again?
Yes, ma'am.
Okay, thank you.
Good question. For this value, the 2 value, it's in the f of x position. So that means that I'm going to find what x is. And perhaps, is it easier for you guys to understand which way to do it when it's in the table like this? Because it's clear that this is going in the f of x part?
I personally thought it was more confusing with the table.
Oh, okay.
But same, I guess.
Really? Okay. So you like it better when they verbally ask you if f of x equals 2.
Yeah, it's a lot easier.
Find x. Yeah, it's a lot easier. That's easier for you? Okay, good to know. How about you, Sophia?
What did you ask?
Do you like the table better, or do you like it when they ask the question directly like this?
The question.
Okay. Eli, what about you?
I like the table a lot.
Okay. All right. I completely understand both directions. Usually, usually a lot of times for people, a table does lay it out a little bit better. And sometimes I'm curious, are you more of a visual learner, Eli?
Yes, ma'am.
Okay. That usually is the case. And also that's kind of that visual kinesthetic, because believe it or not, a table is kind of a way to lay things out and almost not really quite feel it, but you get an idea of it greater. But sometimes for me, at first, tables could be confusing because I'm more of a verbal kind of learner. But, you know, after looking at tables for a long time, I get it now. But I think in the beginning I was more like Sophia and Sam. But I do understand my more visual learners. This is a good format because it's very clear as to which one they're looking for. So I get it. It's just, I just love to hear how different students learn. It's a blessing, and it helps me to know to be able to direct certain instruction also when I'm in class. And then I know you all loved number 24, didn't you?
It was very fun.
Yeah. Yes, I thought you all would like that. But it was nice. This was a gift. The 0 was a gift because you've got f of x equals -7/2 times 0. So that's just 0. So that's 0. And then, oops, that was supposed to be 0. And then we have 2. So they really weren't that bad. And then for the last one, oops, we have to find x when f of x is 14. And in order to do that, you have to multiply. To clear the fraction, you multiply by the opposite reciprocal, or by the reciprocal. So 4 equals x.
So for number 25 and 26,
Wait, was that positive? Wait, was that positive? I must have done something wrong.
No, it wasn't. No, it wasn't. It was negative. Good catch.
Oh.
Because you're multiplying by negative 2/7.
Thank you.
I did it on the one side, but not the other. So there you go. And Miss Sparks always says, whatever you do to one side of an equation, you need to do the other. But I didn't do that well. Okay. So on number 25, and I believe this one was asked of me as well. On number 25, what we'll notice is they are in function notation form because you've got g of x equals x minus 5. And something that I stated earlier, and I believe it was Sophia and it might have been Sam as well, who said that they prefer graphing when it's in the slope-intercept form, which is this mx plus b. Yeah. You'll notice that when it's in function notation, it's already always in mx plus b. So when you're given a function in function notation, you can kind of know that it's going to be in that slope-intercept form. So what would our slope be on number 25?
1 over 1, or just
1 or 1 over 1. Good job. Because you're thinking of it as rise over run. Good job. What is the y-intercept?
-5.
Good job, ladies. So once again, yay, it's in increments of 2. So I'm going to have fun graphing -5, 2, 4, and then I believe -5 is going to be right here. And then we've got a slope of 1 over 1. So 1, I'm going to go up 1 over 1. But, I can actually go up 2 over 2 because it's going to be the same thing. But so, and then it says to compare the graph to the graph of f of x equals x. That's just the parent function. And basically, it's going to run pretty parallel to it, except it's shifted down by 5 because the y-intercept goes through -5. You would not have to do anything like give me any type of verbal written out anything. I just want you to know that this is the parent graph.
So we only had to draw on the graph.
Right. You don't have to say anything. If you said something, praise the Lord. But, if you didn't, I'm certainly not going to say anything.
So we don't have to write anything on the graph.
No. I mean, if you wrote that the slopes were parallel and it was shifted down 5, that would be great. But like I say, you don't have to.
You have to,
and on this one, yes, just be able to graph the parent graph, which it's just basically a line that runs through the origin.
Yeah.
It goes up 1 over 1 or up 2 over 2 in this case.
So for number, would see the graph or put the slope.
Repeat that because you were kind of going in and out. I'm really sorry about the sound quality.
Would you say see the graph, or would you write the graph, or would you write the slope?
Oh yeah, see the graph.
Okay.
See the graph would be fine. I mean, if you wanted to write the slope and the intercept down, that would be great too inside there. But if you just wrote C graph, that would be good. I probably, you might want to write 1 and then B equals -5 and then C graph. And then down here, the slope would be -1/2. Well, Miss Sparks. And the y-intercept technically is 0 because there's nothing there.
Should we maybe label them? Or put them in colored pencils?
You don't really have to. For the most part, I will probably know. On this one, I will know for sure because it's going to be dropped down 5. On this one's going to be kind of interesting because this is really close. Because if we look at it, it's not too close. It's going to be 2 lines that kind of intersect each other. But we're going to go down 1, right 2, or up 1, left 2, as the slope is -1/2. And then the parent graph looks like this. So you really won't have to label it. I'll know the difference.
So those aren't
have to write.
Okay, so Sophia was asking a question and then somebody else had a question. So Sophia, what was your question?
I think I graphed it all wrong. Oh wait, no, never mind. I just didn't add a negative.
Oh, okay. All right, and Sam, was that you or was that somebody else who asked a question?
What? Do we need to write the slope and the y-intercept? Or just say C graph?
You could just write C graph. I mean, if you wrote the slope and y-intercept, that would be great. A great exercise almost for yourself personally to know that you're always knowing what the slope is and the y-intercept, but it's not in the instructions. So I can't very well say, write the slope in that. It says graph the function and then compare it to the graph of f of x. So basically you're going to be drawing 2 graphs. In my world, what I've asked for there is for you to draw 2 graphs. Let me see what the instructions are on the actual test. Let me see if I can find it. Oh. There's actually not even one on there like that.
Oh.
For the most part, on the slope and the y-intercept, there are actually 6 questions like this.
That's easy enough.
On the test. That's easy enough. So just so that you know, there are 6 questions like that. There is 1 function table like that. And then instead of the second ones being like the function table, Sam and Sophia, the questions are asked like this. So you'll have to find f of x for with a given value of x, and then you'll have to find x when given a certain value of f of x. Okay? I will help those people who don't understand that. I will help you a little bit tomorrow with getting that straightened out. But you're being tested on both ways, which I believe in the book, yesterday we had to do it both ways. I think the first set of questions, I think beginning with number 3, were where you had to plug in some x values. And then beginning with number 15 on yesterday's classwork, you had to find a particular value. Yeah, and it's actually on the test. So look back over numbers 15, 17, 19 on yesterday's classwork, 3.7, and make sure you know how to do those because the questions look exactly like those.
Wait, 15, 17 from number 25 onward?
From yesterday's classwork. Yes, ma'am. Make sure that you know how to do those.
Weren't those just like find x? F of x equals something?
Yes.
Okay, so
that's exactly it.
So it's basically the table.
Yes, there will be 2 of those. I'm gonna open the page so that you guys know exactly what I'm talking about, okay? There will be 2, except you won't have to do multiple. On numbers 3 through 11, where you had to evaluate the function at a particular x value, there will be 2 of those, except you're going to only be evaluating for one value. You know how y'all were not very happy with me yesterday because you had to do each one for 3 different values?
Yep.
You will only have to do it for one value. There are 2 problems like that. And then there are 2 problems like 15 and 17, where you are given the value, like the 2, and you had to plug that in for the g of x and then solve for x. There are 2 on the test like that.
Like which?
Like numbers 15, 17, 19, and 21. Okay? There's
Those
2 on there like that.
Those ones for x?
Say that again. You broke up.
Never mind. So you write it negative 13 equals 4x plus 11.
Yes, that is it. And then you solve for x. In the instructions, it says find the value of x. So that is the big hint for you all to know that you plug in that negative 13 in for the j of x or n of x or f of x or whatever the function name is. So there's 2 like that. And then there's 2 like number 3 through 11, where you're going to be plugging in a value for x and finding f of x.
I think the test will go well.
It will go great. Y'all have done great in Math Lab. Are there any questions that I have not covered? I do think there was a student that emailed me about going over domain and range. There will not be any questions on domain and range. So I think what I'll do is I'll put that in a review and we'll go back over it because that is a very important question to ask. And I'm very happy that someone asked me about it because going forward, it's a very, very important concept. but there will not be anything like that on the test tomorrow. So we're going to hit that up on a review after this unit.
Was that me who asked that? I asked for identify the range.
I'm sorry, say that again.
I had questions on identify the range.
Identify the range?
Yes.
There won't be anything like that on the test tomorrow, but do you still want me to go back over that?
It's fine.
Do you want me to is it okay if I hit that on a review, or do you want me to stay, I could even set up a second Google chat for it.
We can do it on
a Okay, because I was going to say it's a really good question, and I really appreciate the fact that you ask it. Especially, it fits very, very well into those function tables because your range is always going to be, those Y values. But we obviously have seen that because a line goes on forever and ever and ever, the range, obviously can be, infinity and stuff. And I will definitely say on all of these lines, really your domain and range on a line, because it extends in both directions, both on the X axis and the Y axis. The good news is for all these linear functions that we've been dealing with, the domain and range is all real numbers for all of them. We haven't really dealt with anything that hasn't been since that last unit.
Yeah, that makes sense.
Okay, good. All right. Are there any other questions?
No, ma'am.
Okay. I'm praying for you guys. I love y'all.
Thank you.
Okay, have a great afternoon. All right. Bye-bye.